Okay.
All right. Good afternoon, everybody. Welcome to the SatMOC virtual training session in the summer for the students, primarily for the students. So this is a SatMOC stands for MS Satellite Meteorology, Oceanography, and Climatology Committee. And so my name is Jun Wang. I'm a professor in the College of Engineering in the University of Iowa. And join together with me, there are other about 10 working group members, and I will put their names in the chat pretty soon here. And today, our session, the working group planned up in total 4 sessions. The first session started last month, and today is the second session in the series of the training. And we are very glad to invite Dr. Amy Huff from NOAA NESTIS to give talks about analyzing atmospheric smoke and blowing dust using satellite aerosol optical depth data. Dr. Amy Huff is a senior research scientist in the NOAA NESTIS Center for Satellite Application and Research. She has a PhD in chemistry, a master's degree in meteorology, and she is now a outreach person also in NOAA to engage the end users of satellite data, especially for aerosols. And you can also find her in Twitter through Aerosol Watch. So with that, Amy, the floor is yours.
Great. Thank you very much, John. All right. Welcome, everyone. I'm so glad you could join us today. So I'm Amy. I'm going to actually turn off my camera now just to kind of save bandwidth and make things run a little bit more smoothly. But I at least just wanted you to see me, see my face at the beginning, so you can kind of, put my face to my name here. All right. So let me turn off the video. Okay. And we can get started. So you can see on this first slide here, you can see the agenda. And so we're going to go over a few logistics, and then we're going to go right into an introduction, kind of an overview of aerosol optical depth for smoke and dust. And then we'll have 2 hands-on exercises using Python. And so just if you weren't able to get Python set up, don't worry, it's no problem. I'm going to do kind of a live demonstration. And if you're still interested after the session and you had problems getting Python set up, you can just email me and we can solve whatever problems you are having. Okay? All right. Let me see if I can advance the slides. Okay, here we go. So in terms of logistics, we're going to use Slido for, I have 4 interactive questions for the participants, and then also for any kind of Q&A. So if you could please not put any questions from now on into the Zoom chat. So we don't want to use the chat because I can't see it when I'm leading the presentation here. So if you can, please, instead of using the chat, use Slido. Okay, and so what I'd like everybody to do now, please, is to open Slido in a separate browser tab. And if you can keep it open for the duration of the presentation that I'm going to make here, the slide presentation, that'd be great, because we're going to go back and forth a couple times with some questions. So please open up slido.com. So you can see there, hopefully it's slido.com. And then there'll be a blank space at the top when you do that to ask for the code for your session. So it's SAT, lowercase, capital S, lowercase at, and then capital MOC, capital T, and then training, the rest of the world, -2. So let me go there right now. Hopefully, whoops. I've got too many browser windows open. Okay, so hopefully you guys can see that. So you should, when you get everything set up, it should look something like this. So the first question under polls should be up. And then there's also, if you click, there's also Q&A. And this is where you want to type in, if you have any questions, type them in there. Okay, and I'll stop periodically and answer any questions that folks have. Okay, but for now, if you could please answer this first question. Have you completed the 3 homework assignments? Excuse me. Yes or no? And then when it looks like everybody's answered that question, Bill's going to tell me the results. So I'm going to go back to VIIRS.
Yeah, people are clicking in.
Okay. So again, you want to go to slido.com, and then the code is SatMOC training-2. So give people a chance to do that. So as folks are answering that question, just to let you know, there were 3 steps to the homework. So one was to watch 3 relatively short videos covering background information about satellite remote sensing, and then about the ABI sensor and the VIIRS sensor. And then the second step was to download Python code files and a VIIRS AOD data file. And then the last step was to set up Jupyter Notebook and upload those Python code files in the AOD data file. So if you didn't have a chance to do those, it's okay. So what you want to do is, you may have some trouble if you didn't watch the background videos and you're not familiar with satellites or aerosol optical depth. You might be a little confused here and there, but you can always, watch those videos afterwards, and that should bring you up to speed. And in terms of the Python hands-on, as I mentioned, if you didn't have a chance or weren't able to set up everything, that's okay, because I'm going to go through everything live. And then if you still are interested after the session, email me and I can help you set everything up. Okay? So what are the results of our poll question, Bill?
So we've had 24 people respond, and we're right at 67% said they have, and 33% said they haven't.
Okay, well, that's pretty good. Okay, great. So the majority of people were able to do the homework, so that's terrific. Okay. All right, so do we have any questions, Bill, before we get started? Are everybody good? Okay. All right, so let's jump right in. And so again, the topic of this session is related to smoke and dust in the atmosphere. And so the reason why is because smoke and dust aerosols, they're hazardous to human health and human welfare. So they degrade surface air quality, so fine particles air quality, which is also called PM 2.5, and coarse particles air quality, which is also called PM 10. And so aerosols also reduce visibility and have impacts on aviation. And these impacts on human health and welfare can range from the micro scale up to the synoptic scale. So smoke aerosols, they originate from fires, of course. So there's kind of 3 different types of categories of fires. So there's wildfires, and those tend to be the largest. There's also prescribed fires or planned fires for land management. And then seasonal agricultural burning, and that happens at different places around the world. Kind of one of the closest ones to the US is in Mexico and Central America in the spring. That's when their seasonal agricultural burning season is. And dust aerosols, those are lofted up into the atmosphere from arid regions. So deserts are big sources of dust. So they can be large deserts such as the Sahara in Africa, or the Gobi and Taklamakan deserts in Asia, or smaller deserts like the Mojave or the Chihuahuan deserts. And then also dry lakes, which are called playas. They can be sources, smaller scale sources of dust as well. And so dust and smoke impacts are becoming more frequent and more severe in recent years. And so that leads us to I just have a few examples here for the past few years of news events related to fire and dust. So you can see on the left, the top left, in June of this year, 2021, there have been many extreme fires in Arizona. And so you can see an example of one of them there. And then the lower left, in March of this year, there were several dust events that impacted Western Texas. And right in the middle, you can see kind of that orangish colored picture. That was from last fall, September 2020. There were a series of extreme wildfires in the Western US. And so there was one day that the smoke was so thick over Northern California that it caused the skies to be orange. Then also last year in June, there was an extreme Saharan dust event, and that dust traveled all the way across the Atlantic, and it reached the Gulf Coast states including Texas, and it caused air quality alerts. So you can see an example of what the skies look like. That was Houston, that picture in the top right. And then in the lower right and kind of the lower middle, 2018 was another year for really serious wildfire activity. And so you can see an example of a photograph of Seattle, the Seattle skyline from September 2018. And then also that year, so that the smoke and dust doesn't have to just be isolated to the locations of either the dust sources or the fires themselves. Those aerosols can be transported long distances. And so in September 2018, smoke from California reached all the way to the East Coast, and it impacted Washington, D.C. and Baltimore. All right, so that leads us to kind of these increases in extreme events, kind of understanding where the smoke and dust are and what their impacts are. That leads us to aerosol optical depth, which is abbreviated AOD. It's also called AOT, or aerosol optical thickness. And this is a remote sensing measurement. So it can be satellite, ground-based, or what they call suborbital, which means it can be on airplanes. And so AOD is a quantitative measure of the amount of aerosols in the atmosphere. Okay, so that means that AOD is high for thick aerosols like smoke or dust, and it's low for clean or clear atmosphere. And so you can see an example here. So on the left, you can see a true color or visible image showing smoke across the continental United States from September 16, 2020. And that's when the smoke from those western US wildfires was transported across the continental US. And then on the right, you can see the corresponding aerosol optical depth. And so you can see with the color bar, those red colors indicate very thick aerosol, so thick smoke. And where you see it's blue, that means it's clean or the skies are clear. Okay. So let's go to Slido really quickly. I was just wondering if any of the participants have ever encountered satellite AOD before in your studies or research. Anybody ever heard of AOD or used it before?
Okay, the votes are coming in.
Okay.
And we've reached the number we had in the first one, 24.
Okay.
Believe it or not, there's a 25th one come in. We have 64% said yes and 36% said no.
Okay, great. So that means there's a majority of people that have actually heard of AOD before and used it as possibly as well. So that's terrific. Okay. So for those who aren't familiar, let me just cover a few details. So we're going to focus today on AOD that's from the ABI sensor on the GO-16 and GO-17 geostationary satellites, and from the VIIRS sensor on the SNPP and NOAA-20 polar orbiting satellites. So for both of those satellite AOD, the data range is from -0.5 to 5. And AOD is unitless, so there's no units. And so what that negative value means, it just expresses the uncertainty in the AOD retrieval. So you can think of those small negative values as essentially being very small positive values of AOD. Okay, and so you can see the range there is typically from 0 to 1 in the United States. And if you look at the color bar included there, you can think of the kind of darker blue color as being clean AODs, the kind of lighter blue color as being very thin aerosols, kind of the cyan to green colors as moderately thick aerosols, and then the orange to red as being thick aerosols, and then the dark red color, anything greater than AOD of 1, as very thick aerosol. So just kind of a loose way to interpret aerosol optical depth. And so I have a chart here. And again, this is just breaking down the differences between AOD from the two sensors. So anybody who watched the background videos knows that the spatial resolution is going to be slightly higher for VIIRS compared to ABI. And then the coverage is different. So VIIRS on the polar orbiting satellites has global coverage, whereas the ABI on the geostationary satellites just has coverage of the Western Hemisphere. And you can see the availability of the archive going back for the satellite products. And the maturity level, the thing to remember there is that because ABI, it's on satellites that have been launched more recently, the data aren't what's called fully validated but there's still, so that means that there could be small improvements that are happening, but they're not probably something that as a user like yourselves, you're going to necessarily notice. So you can use the ABI and VIIRS AOD pretty much with full confidence for any of your research or your work that you might be doing. Okay, so I just want to touch briefly on the AOD algorithms. So AOD, what it is, it's derived from the extinction. So that's the scattering and absorption of backscattered sunlight by aerosols. And so aerosol optical depth depends on wavelength. So for ABI and VIIRS, they report AOD at 550 nanometers, so right in the middle of the visible spectrum, okay? And so what an algorithm is, it's the formula that's used to calculate, or we say retrieve, AOD. All right, so remember AOD, it's called a level 2 product. That means that it uses the ABI or VIIRS radiances. So those are the ABI or VIIRS bands or channels, the level 1B data as input. Okay, so the trick or the challenge in retrieving AOD is that you have to isolate the extinction of backscattered sunlight by aerosols. But there's a lot of other things in the atmosphere that are causing that extinction of sunlight. So basically you have to separate the aerosol signal from the surface reflectance, scattering by clouds, and absorption by trace gases in the atmosphere. And that's the tricky part. And so the way the science teams do that is they use what's called a multi-band or multi-channel AOD algorithm. All right, and so you can see, for an example here, I have the table that shows the bands of the VIIRS instrument that are used in the AOD retrieval, and also what are called internal tests. Okay, so that the VIIRS or the ABI bands are similar. They're slightly different, but they're similar. And so there's different algorithms for AOD retrieved over land and water. And the key feature of the multi-band or multi-channel AOD algorithm is that the 2.2 micron band, so that's M11 for VIIRS, it's used to estimate the surface reflectance. And that's a very tricky part of the AOD algorithm, is trying to separate out the surface reflectance. And so I mentioned the internal tests. So those are tests to screen for unfavorable conditions where it's either difficult or impossible to retrieve AOD. And so the AOD data files, they come with what are called data quality flags, and these express the confidence in AOD data. And so the figure shows an example of the ABI AOD quality flags, and the VIIRS AOD quality flags are very similar. And when we do Python, we'll work with the quality flags later today. But just to give you an example of kind of what they look like. So high quality AOD, that's everything in the image that's shaded in the darker blue. That's the most accurate AOD. So the algorithm is very confident that AOD is correct. Okay, so you want to use, if you have a quantitative application like modeling, data assimilation, you want to use the high quality AOD. Medium quality, so that's everything that's shaded in the lighter blue in the figure. So that has some uncertainty, but it's probably fine. So it's got pretty high confidence, but not quite as high as the high quality AOD. So you can use this for qualitative applications like any sort of operational forecasting application, for example. And then the low quality, so that's anything that's shaded green in the figure. That means typically there's one or more of those internal tests that were failed. And so, the algorithm really thinks it probably is AOD, but there's a lot of uncertainty that you just can't be sure. So you generally want to avoid the low quality AOD for most applications. And we'll see some examples in the next slide. All right. And then anything that's shaded brown is where AOD is not retrieved. So where there's clouds, there's snow or ice on the surface, there's sun glint. So sun glint is a measurement artifact, and it occurs when sunlight reflects off the surface of a water body at the same angle that the sensor, either ABI or VIIRS, is viewing the surface. And you can see in the image that dark brown kind of semicircle in the middle there. That's an area of sun glint, and so AOD isn't retrieved there. And then also for ABI AOD only, there's no retrievals over bright land surfaces like deserts, for example. And then of course at nighttime, because this is AOD at 550 nanometers, so we need visible light, so there's no AOD at nighttime. All right, so just to look at some examples of that high, medium, and low quality AOD. So we're going to look at, this example is smoke from 2 wildfires that were burning near Los Angeles, California. on December 3rd, 2020. And this is actually the same event that we're going to work with when we do the Python hands-on exercises. So this first image here, this shows the high quality AOD. So again, this is most accurate, but you can see there's definitely data gaps, right? So here's Los Angeles. The fires are just to the southwest of Los Angeles. There's some AOD missing over land. There's quite a few large gaps here over the ocean. And then you can see along the coastlines and around the islands, there's fairly large gaps as well. It's because the AOD has very stringent screening. So if now we look at the medium quality AOD, we'll see, I can flip back and forth. So we'll see a lot of those gaps in the AOD over the ocean and some of them over the land have been filled in now. There's still, some gaps along the coastlines, but generally we've got most of the smoke plume resolved. All right, so now if we add the low quality in. So again, this is high and medium, and now we add low quality. So you can see now we've resolved the whole plume when we look at the low quality. So again, that's high medium, and this is all quality. So we can see the whole plume, all those gaps are filled in. A lot of the gaps over the plume over the land are filled in. But the problem is if you look along the coastlines, you can see there's a lot of high AOD along the coastlines. That's erroneous, and then around where the little islands are. So that's actually erroneous high AOD retrievals, and there's some inland as well here. All right, so that's the problem. So we resolve the whole plume, but with the low quality, we get these additional erroneous AOD values. So the thing I want you to remember is just to know, when you're working with satellite AOD, just know what the quality is. And if you do use low quality AOD, make sure you understand what it's showing. Our general recommendation is to use the high plus medium, which we call the top two qualities, for most applications. Okay, so here's our next Slido question. So this is a comparison for the same event. This is also off the coast of Southern California and Mexico, but it's a different event. This is October 2019. So you can see the GO17 ABI AOD on the left, and then the SNPP VIIRS AOD on the right for just about the same time periods. So in Slido, just type in any differences that you notice between the two sets of satellite imagery. So what do you notice that's different between the left and right images? All right, do we have any answers coming in, Bill?
We do, but they're coming in
a
little slow. People are putting some thought to it.
Yeah, it's okay. You want to just shout some of them out to me then as they come in, please?
Well, certainly the resolution is getting the higher resolution from VIIRS is getting some play here.
Right. So that's a good one. So you can see the ABI image looks a little more pixelated, right? And that's because the spatial resolution there is 2 kilometers at nadir versus VIIRS, which is 750 meters. So you can kind of discern more of the kind of the texture and the features of the plume with the VIIRS. That's a good one. What else?
And certainly the ABI in the geostationary orbit has a higher temporal resolution, so people are jumping on that.
Yep. So that's a good point. So obviously the image on the left is dynamic. So we're getting observations with a CONUS view every 5 minutes, although here we're showing every 10 minutes. But you're getting that high temporal resolution, so you can see the evolution of the smoke plume. Whereas the VIIRS on the right, it's just going to be a static kind of snapshot of the aerosols in the early afternoon because it's on the polar orbiting satellite. Anything else, Bill?
So there was one that said that ABI has less land coverage.
Yes.
I'm not sure. Yeah.
Yes, that's great. I'm really excited somebody picked that out. That's very subtle, but that's exactly right. So you can see, well, let's look at the VIIRS first. So on the VIIRS on the right, you can see these kind of blue pixels over the land. And that's kind of, this part of California and Mexico is kind of deserty. So this is considered a bright land surface. So, and again, this is subtle, but VIIRS has a slightly different AOD algorithm that can retrieve AOD over these bright land surfaces like deserts, whereas the ABI AOD is running a slightly different algorithm. So you can see there's fewer of these VIIRS pixels, of these blue pixels over the ABI. There's more kind of blank spaces where you can see the ground. And that is one of the features of VIIRS compared to ABI. This retrievals over bright surfaces. Anything else?
Then I have overestimation of particle distribution on ABI versus VIIRS.
I'm not sure what that's referring to, but that's okay. We can always come back to that later in a question. Anything else?
The one that says more red on ABI. ABI shows less blue over the land.
Yes, well, that was what we just, that's what we just referred to. Great. Okay, it sounds like people got most of them. So this is a summary here. The one that you couldn't really tell from those two images is, again, don't forget the coverage is different. So because the ABI AOD is on the geostationary satellites, it just has coverage over the CONUS in the Western Hemisphere, whereas VIIRS, because it's on the polar orbiting satellites, has global coverage. Okay, but everybody else got all the rest of them. That's great. Okay, so
before you go on, is where the orbits of 16 and 17 important, where AOD on a limb may look a little different than AOD at nadir?
Well, so yeah, that's a good question, which we didn't really have time to get into too much. But the main result is that if you look at the top two qualities, so the high plus medium qualities, the AOD for the CONUS V will cut off after a certain point because of the uncertainty in the low satellite angle. So we'll see some examples of that when we do the examples here. All right, good question. All right, so I just wanted to mention briefly, we don't have time, unfortunately, to go into a lot of details, but there are a lot of applications of satellite AOD, both in research and operations. So I have some of them listed here. So again, it sounded like 60% at least of people, participants had encountered AOD before. But some of the most common applications are in weather and air quality forecasting, and then numerical air quality and smoke modeling. Also pollution trends and source identification, particularly related to PM10 and PM2.5 pollution, as well as climate through the aerosol relationships with clouds, precipitation, and radiation. And I just put an example here. This was from a recent blog post of National Weather Service forecasters using ABI AOD to help track smoke from wildfires that happened a little bit earlier this year in mid-June. Okay, so before we go on, we're going to look at some examples. Just keep in mind the strengths and the limitations of satellite AOD. So the main limitation is that it's a column measurement. So we're looking at the geographic two-dimensional location of aerosols only. AOD doesn't provide any information about the vertical distribution of aerosols in the atmosphere, meaning smoke or dust may not be reaching the surface. You can't tell from AOD. All right. And then, of course, there's no AOD in areas with clouds, snow, ice, sun glint, or for the ABI AOD, those bright land surfaces. And then it's available during the daytime only. But in terms of the strength, so even though it is a 2D measurement, there are many studies that have correlated surface concentrations of fine particles and coarse particles with AOD. So it still provides a lot of useful information. And as we'll see, it's easy to interpret and identify areas of high aerosols, and then it supplements the visible imagery of smoke and dust. Basically, in my opinion, it makes it easier to pick out areas where there are smoke and dust aerosols compared to looking at a visible image. And just one more limitation before we go. This is more of an artifact. Sometimes you'll see for very thick aerosol plumes, so really thick dust or really thick smoke, the AOD algorithms are misclassifying that aerosol, that thick aerosol, as a cloud. So the algorithm thinks it's a cloud, so it's not retrieving AOD for those locations. Okay, and it happens both with ABI and VIIRS AOD over land and over water. And this is just an example from last year. This is showing smoke from wildfires in Oregon and California. And you can see, if you look at the AOD on the left, this is all qualities AOD. where the smoke is really thick, the AOD is missing, and that's just because the algorithm thinks it's a cloud. All right, so you might encounter that, and that's just more of an artifact. It's just related to the way the algorithms work. Okay, so let's look at some examples. So this is fresh off the press. This is yesterday. So we're looking at ABI AOD from Go16. And this is a loop from yesterday morning, and you can see the orange, yellow, and red colors, and those are the thickest smoke, and then there's the cyan and green colors with slightly kind of moderately thick smoke. And this is smoke from wildfires in Ontario and Manitoba that was transported to the eastern US, and it's still here this morning, by the way. Okay, and so here's another example. This is from mid-June. And I like this example because, again, this is Go16 ABI AOD as well. So you can see in the middle, kind of the upper Midwest, we have smoke, high AOD of smoke from wildfires that were occurring in Arizona and Utah. And then we have kind of in the lower left there off the coast of Florida, some moderately high AOD that's associated with Saharan dust that was transported from Africa. And so to go back to Bill's question from before, you can see how the AOD cuts off kind of over the Rocky Mountain states in the upper Midwest. And that's the extent of the Go16 high plus medium quality AOD. So any AOD beyond kind of to the west and north of this is considered low quality. And so that's why we don't show it on our website where this image was taken from. Okay, so let's look a little bit more closely at that Saharan dust. So these are images that I created with Python. And so you can see I'm going to loop through these 4 days. So you can see the high AOD, the kind of yellow, orange, and red colors. There's a plume of Sahara dust coming in from east to west. And then there's already one that's over the Caribbean here on the 13th, 14th, 15th, and 16th. So you can see it gradually moving from east to west, and then another plume coming in behind it. We've had a lot of Saharan dust plumes moving across the Atlantic this year. So this is another example. Now we're still looking at Saharan dust, but now we're over the Mediterranean Sea, so looking at North Africa and Southern Europe. And so this is SNPP and NOAA 20 combined VIIRS aerosol optical depth here on the left. And so there's one thing that I wanted to point out. With the polar orbiting satellites, again, you're going to have areas of sun glint. They're circled in yellow here. And this is an artifact where the sun is reflecting off in this case, the Mediterranean Sea surface. So you don't have AOD retrieved in those areas. But because SNPP and NOAA 20 are their orbits are 50 minutes apart, their sun glints are in different locations. So you can overlay the AOD retrieved from VIIRS on the two different satellites, and that'll fill in the gaps caused by sun glint. Although sometimes when you do that, you can have discontinuities, like I have here circled in white, where you can kind of see a very sharp gradation between the AOD captured from one satellite, or VIIRS on one satellite versus the other. Okay, so that's the only limitation with that. So now let's look at blowing dust. So this is an example from, on a smaller scale now, from Oregon from mid-June. And so hopefully you can see in the geocolor imagery, there's apply a small dry lake bed here, kind of the central south part of the state, and it's blowing dust to the northeast, and the ABI AOD picks that up pretty nicely, but there are still some gaps due to the bright surface of this part of Oregon. So one thing we can do to ameliorate that is we can do a composite. This is a 3-hour composite AOD image, and you can see that does fill in there's still a few gaps, but that does fill in some of the gaps that were caused by clouds and by the missing AOD of the bright land surface. Okay, so here's another example. This is now SNPP VIIRS AOD showing wildfires in Arizona on June 21st of this year. There were a lot of wildfires. I've kind of marked them all here with the red X's in my AOD image. So you can see the dark red colors indicating high AOD greater than 1, corresponding to some of these plumes, and then the corresponding true color image on the right. Again, I think for me, it's a little bit harder to see some of the big plumes are easy to tell, but some of the smaller ones, like in southeastern Arizona, I feel like they show up a lot more clearly in the AOD compared to the true color image. Okay, And then this is another VIIRS AOD. I just wanted to show an example from someplace outside of North America. So here now we're looking at Russian wildfires in May of this year. This was in southern Siberia near the border with Kazakhstan. And you can see the very thick plume of smoke associated with these wildfires in the dark red shading. All right, so this is the last example. So this is GO16 ABI AOD from Central America seasonal burning in May of this year. And so again, on the left, we have the composite. Again, the compositing is helpful to cover or to fill in gaps due to clouds or to missing AOD retrievals for any other reason. And then we have the corresponding animation on the right. And the reason I put this in is because I just wanted to remind you, if you're working with ABI AOD, you want to keep in mind the different views. So the CONUS view, the view sector, ends, like it cuts off around 15 degrees north. So if, for example, this image I made on the left here, if you want coverage below 15 degrees north, you need to use the full disk view sector of ABI AOD. So that's just something to keep in mind when you're working with the actual products, the data files, if you ever do that. Okay, and let's talk about that. So first, where can you find prepared imagery? All right, so I've shown some examples from two different websites, NOAA websites, the Aerosol Watch website on the left here. So Aerosol Watch has VIIRS and ABI AOD. So the only limitation with the VIIRS AOD is that even though VIIRS has global coverage, Aerosol Watch just shows the coverage over North and Central America. And it has, both these websites have near real-time imagery and an archive. So you can see listed there when the archive starts. And then for JSTAR Mapper, that JSTAR Mapper just has VIIRS AOD, but it has a global view. All right, so it has all the full global coverage of VIIRS from SNPP and NOAA 20. And again, it's near real time, and you can see there when the archive starts. And I've included a link to tutorials to navigate each of these websites. Okay. If, however, you want to actually work with AOD data directly, or you want to make your own imagery, like I've shown you some examples of when I made my own imagery, you have to actually access the data files. So they're in NetCDF4 data format. And I put some supplemental slides on the AMS website where you access the homework. Those supplemental slides will give you more information about the ABI and VIIRS, how to decode the file names, and then understand the file contents. Okay, but for today, the things to remember are that any of the ABI level 1B data files, so those are the radiances, the channel 1 through 16 radiances, or any of the level 2 data files, and that includes AOD, they're available from the NOAA Data Archive on Amazon Web Services. So there's separate links, or they call them buckets, for GO16 files and GO17 files, and so I put the links there. So you can actually download files manually, or using a coding program. We're going to use Python. So there's no registration. There's nothing you can do. You can just go, boom, download these files. It's really easy, and we'll see an example of that when we do the exercise. So in contrast, the only way to access VIIRS level 2 granules files, and that includes AOD, is from NOAA's class website. Okay, and so the data files, it's a little more cumbersome. They have to be ordered, and then you get an email from class, and you have to download the files manually, and you have to register. It's free, but you still have to register in order to download the files. So I have a very detailed, fairly long video tutorial that shows you the steps from start to finish. One detail to keep in mind is that when class downloads the VIIRS files for you, they're going to come bundled in tar files. Okay, so I included in the supplemental slides a Python function that will unpack the tar files that class provides and extract the individual NetCDF files. Okay, so if you're looking for that, I provided that for you. But for today, just to make things easy, I gave you the VIIRS AOD NetCDF file that we're going to use, so you should have that for people who did the homework. And then Dr. Lindstrom, who led the first session, he actually prepared a shorter 9-minute video that highlights the steps, how to order the file that we're using today, how to order that from class. Okay, and the link is there if you're interested in that. Okay, so we're running a little bit behind, but I think that's okay. So that leads us to the Python hands-on exercises. So for those of you who were able to do the homework and get this set up, you should have downloaded, or excuse me, I'm sorry, what we're going to do today is we're going to download 3 Go16 ABI AOD data files from Amazon Web Services, and then we're going to, so then you'll have 4 data files. You have 3 ABI files and 1 VIIRS file, and so then what we're going to do is we're going to open those up, we're going to process them using the data quality flags, and then we're going to plot the AOD data on a map, and we're going to save that as a professional quality image file. And we're going to do that for all 4 files. Okay. So if you were able to get Python set up in Jupyter Notebook, you should have something that looks like what's on the screen there. And hopefully everybody already ran this program, the Python check packages. And that's just to make sure that you have the necessary packages that we're going to use today installed. And that your version of matplotlib, which is the mapping package, it's up to date. Okay. So Bill, do we have any questions in the Q&A before I go on?
We actually do. Let me go through.
Okay.
Let's see. Is there a diurnal variation on how AOD shows up and goes in JPSS?
So not in JPSS, because again, those are always at the same relative local time. But ABI, because it has observations essentially from when the sun rises to the sun sets. So there are some subtle variations that I don't have a lot of time to talk about right now. So I can, I'll describe those in a short document, and I'll post them to the training website, because it's a little bit complex to go into. But there are some subtle small issues that users could be aware of. That's a good question.
Okay. The second one is, will the source of AOD show up differently on GOES or JPSS? I guess maybe what the content of the AOD, what sort of smoke or dust is causing AOD? Will it show up differently?
I'm not 100% sure what this person is asking, but I don't think so. So again, the algorithm, so the recipe that's used to retrieve the AOD is slightly different for VIIRS versus ABI, but the fundamental concepts are the same. So they're both AOD measurements. They're both looking at the extinction of visible sunlight by the aerosols in the column. So kind of fundamentally, they're the same, but there are subtle differences that are related to the algorithms that are being used, as well as to the fact that one's on a polar orbiting satellite and the other one's on a geostationary satellite.
No, I think what this person is asking is, like, if you have, you talked about blowing dust from Africa. So would you be able to look at an AOD blowing dust and say, oh, no, that's from one desert in Africa compared to another one?
Oh, no. No. So in terms of source apportionment, no. You don't get that sort of information from aerosol optical depth.
Okay. All right, so there's 2 more. Why can VIIRS retrieve AOD over bright surfaces while ABI can't?
Yeah, so that's a good question.
Algorithms?
So the algorithm is the algorithm is slightly different. So VIIRS is running, again, I don't want to go into the weeds too much, but VIIRS is running what's called an enterprise algorithm. And so it includes, as part of its algorithm, a way to retrieve the surface, way to account for the surface reflectance over bright surfaces, whereas the ABI algorithm hasn't, it's going to eventually have that feature, but it hasn't been updated yet. So the ABI AOD is running a slightly different version of the algorithm compared to VIIRS. So eventually ABI will also be able to retrieve AOD over bright surfaces, but currently it cannot. Okay,
so another one says, can you when you say you can do a 3-hour composite of ABI AOD, does that just mean the 3-hour mean?
Yes, that's correct.
Okay, that was easy. All right, then finally.
Yeah, so like this is in this example, so this was a 2-hour on the left here, it's 14 to 16 UTC. So that means for each pixel, each location, we're taking the average AOD over those 2 hours and plotting it. That's exactly right.
Okay, so the last one says, can GOES 1617 data sets be opened in RAM with OpenDAP through X-Array to avoid actually downloading the NetCDF files onto my hard drive?
I don't know. I'm not sure. That would probably be a question that user can answer. You certainly can use X-Array. I don't know if you can use, in conjunction with the Amazon Web Services, the program you just described. You might not be able to with the free. So I'm going to show you how to use the free anonymous. You might actually have to have an Amazon Web Services account that you pay for and register. I mean, I'm sure you can do it, but I don't think you can do it with what I'm going to show you today.
Okay, then
so maybe whoever asked that question, maybe just email me and we can, I can work with you directly.
Yeah, and I've reinforced through chat that people asking these should put their name down so that that sort of interaction can continue.
Yeah, that's fine. Those are good questions.
One is, does the Phyton code just for the ABI and VIIRS Net CDF, or does it work for MODIS and MISR, etc.?
MISR. No. So, I mean, MISR and MODIS will be similar. That's a good question. But the way the MISR and MODIS AOD data files, the NetCDF files, actually, I think those are in HDF format. I don't think they're NetCDF files. They'll have slightly different variables inside the file. So the variable names for aerosol optical depth and the data quality flags will probably be slightly different. So that the general concepts will be the same, but the details will be slightly different. So I guess the short answer is no, you can't use what I've given you today directly for MODIS and MISR. It will require some modification. It's a good question.
I think that's the last one for now.
Okay. Yeah, we're running behind, so I better keep going here. So to go back to the slides here, those are all great questions, by the way. Thanks for those. So what we're going to do with Python is we're looking at, you can see the geocolor animation here in the middle. So this is, as I mentioned, this was an event from last December, wildfires near Los Angeles. So we have 4 AOD data files. So we have on the upper left, we have NOAA 20 VIIRS. And then on the bottom, from left to right, we have 3 time steps of GOES 16 ABI AOD. And so what you'll be able to do is you'll be able to specify these different parameters. All right, so I have everything set up kind of with default settings, but if you work with this on your own after the session, you'll be able to modify these different settings. And you'll also be able to, actually I'll go ahead come back to that Slido question. You'll also be able to use the Python code to work with any ABI or VIIRS AOD data files. So they won't work for MISR or MODIS AOD, but any ABI or VIIRS AOD data files. And you can use the code that I provided to download any ABI level 2 data files from Amazon Web Services, not just AOD. Okay. So let's go back and ask our last Slido question. I'm just curious, how many of the participants have experience with Python? So if everybody could go to Slido and answer this last question, please. So there should be 4 options. So basically you're an expert, you have some experience, you have a little bit of experience, or you've never used Python before. Yeah, sorry, whoever just responded in the chat, if you could go to Slido, please, and answer the question, that would be great.
Yeah, and people were answering the question earlier, so I think we're in pretty good shape. 46% say they're proficient, and 38 say they're, well, 40% say they're beginners, and only 16% say they're never worked with Python, and of course, no one is an expert in Python except maybe Amy.
No, I'm not. I'm definitely not. There are some experts, but yeah, Python's so dynamic. It's hard to keep up sometimes. Okay, well, that's great. So at least, you know, it sounds like there's a range. There's some people who are experts, and there's some people who have never used Python before. So the experts shouldn't have any problem.
84% total said they're either beginners or proficient. So at least
Okay.
People knowledgeable.
Okay, terrific. So there's like 20% of people that have never used it before. Okay, so so people who are even beginners and the proficient people should have no problems here. For the people who are brand new, we're gonna run through this hopefully together. I don't have enough time to review the code line by line like I normally would, so I'm just gonna have to go over each major step kind of big picture level. But I have extensive comments. If you have specific questions, I always recommend Googling first. Like, see if you can figure out whatever your question is on your own. And if you're still not sure, feel free to email me, okay? So just a couple notes. After the session, as I mentioned, feel free to email me. That's no problem. I started a discussion thread on the training website. So if you have questions or comments and you don't want to email me directly, you want to maybe put it there, that's fine. I'm going to upload these slides to the training website, so you'll have these slides available to you. We're going to email you a short survey later today, so please fill that out when you get it. And then don't forget about the upcoming sessions. So we have those session 3 and session 4. Session 3 coming up on July 28th and session 4 on August 11th. And both of them are going to be led by Dr. Carrot Wilson from NOAA. Okay? All right. So as I said, we're running a little bit behind, but that's okay. I think we can make it up. So let's move on to Python now. So if people who have this set up, if you could open up your Jupyter Notebook folder. So you should have something that looks like this. So people can see this on my screen, right? So Bill, is this showing on my screen?
Yes, it is.
Okay, good. Okay. So as I mentioned, you should have already run this check Python packages, hopefully. Let me open that up, and you should have, let's open slowly. You should have run that block, and you should have something that looks, you know, maybe slightly different from this, but it should have told you what your package versions are, and that if you can run this without getting an error message, that means that you have all the required packages installed. Okay. All right, so I'm going to close this. And so now let's everybody open up the file that says ABI L2 download files AWS. Okay, so this first one here. You just click on it to open it, and it should open up in a new tab. Probably take a second. All right. So we'll give people a second for that to open up. All right, so the way I like to use notebooks because it's easier for beginners and it's nice for training. But before the training started, somebody asked, because there's some people that prefer to use the Python IDEs like Spider or PyCharm. If you're one of those people, email me and I can send you, if you're interested, I can send you these files in PY format so you can use them with Spider or PyCharm or your favorite Python IDE, okay? So the way Notebooks works is that you click in the code block here. So I'm now clicked in block 0, and you can see on the, hopefully you can see on the left-hand side, there's a green vertical bar that gets highlighted when you've actually clicked on the cell. And then you go up here to the top, this menu with all the kind of buttons, and you click Run. Okay, and that'll run that individual code block. And so you can see with block 0, this just kind of gives some information and documentation. Okay, and then for most of the blocks, so I'm now on block 1, I'm going to click on that, and so now you can see it turns green. Most of the blocks, nothing will happen, okay, because either they're functions or in this case, I'm going to run this one. So block 1, let's run it. So block 1, we're importing the packages that we're going to need to use for this code. And for this program, the most important one, or kind of the main one, is S3FS, and that's the module, the package that we need to interface with Amazon Web Services. Okay, so you can see there's no output, nothing happened, but we didn't get an error message. So that means everything ran properly. And if when you run a block, excuse me, for those of you who are new, excuse me. Let me just get a drink of water there. There's a little number that will pop up in these brackets here. Okay, so now let's move on to block 2. And so all this function does is that we're going to enter the observation day in normal time with a month and a day of the month. But ABI data files are organized by Julian day. So all this function does is that it just converts to Julian day. So let's run that. All right, now I'm on block 3. So let's click on block 3. And so this is a really long block. I won't scroll all the way through it, but all this is doing is that we're going to enter the product, the level 2 product that we're interested in and that we want to download, and the ABI view sector, so full disk, CONUS, mesoscale 1 or mesoscale 2. And in order to download the files, there's an abbreviation that goes with that. And so all this function is doing is that it's just getting the abbreviation for the product name in the view sector that we designate when we enter that. So let's just run that. Okay, and so that's done. So now I'm on block 4. So block 4, this is kind of the main action of this particular file. So this is where we're actually going to be creating a list of the file names for the satellite, the product, and the start and end dates and times that we designate. And so the main places we do that is with this command here. This is where we actually contact the Amazon Web Services archive. And then if we scroll down this line here, this is the command to actually list the files for the specifications that we enter. And I'm just going to scroll over to the end of that command because I just want to point out, so this argument here, refresh equals true, that just allows us to, if we were searching, we're going to search the archive today, but if we were searching for near real-time data files, that refresh equals true argument allows for the update for the near real-time data files. Okay, so let's run this. So again, I'm in block 4. I'm going to run that. So now in block 5, what this block does, it's going to create a drop-down menu to make it really easy for us to select the satellite, the product, the view sector, etc., in order to select the parameters for the data files that we want to download. Okay, so when you run block 5, you should have something that pops up that looks like this. So you'll see all these different pull-down menus, okay, that allow you to select all the different specifications. So for what the files we want to download, we're going to select for satellite, go 17. Under product, we're going to select Aerosol Optical Depth. Excuse me. For view sector, we're going to select CONUS. The year is 2020. The month is December. The day is the 3rd. Okay. And the start hour is 20. The start minutes is 55. Scroll down there, 55. The end hour is 21. And the end minutes are 10. Okay, so you should have, your selection should be go 17 for the satellite, Aerosol Optical Depth for the product, CONUS view sector, year 2020, month December, day 3, start hour 20:55 UTC, end hour 21:10 UTC. Okay? Give everybody a second to do that. So this is where you're selecting in this block with these menus. This is where you're selecting basically the parameters for the files that you want to download. Okay. All right. So once you've done that, you don't have to do anything else. You just select those, pull up the menus, and leave them, and scroll down to block 6. Okay. So block 6. This is where we're actually going to download the files. So the only setting that's in block 6 that you might want at some point, not now, but at some point you might want to change is at the top here, you see Save Path. Okay, that's the directory where the data files are going to be saved. Okay, I have it set up here to save them in your current working directory, which is the same folder on Jupyter Notebook where this code file is. Okay, but if you wanted to change that at some point, this is the setting you would change, and you put in whatever directory is that you wanted to save your data files. Okay, so let's run this block, run block 6, and we scroll down to the bottom here. You should see something listing the data files. Okay, so in this case, there's 3 data files, and then the output is telling you the directory where you're going to be saving the files to, and this is the current. It should be the current working directory. That's the name of mine. And then you have this question: would you like to download the data files? Okay, so if your what you have looks like this, looks the same. So you have 3 Go17 data files. Type either Y or you can type yes. If you just type Y, it's fine, and hit enter. It's going to download the data files. Okay, and then if you go back to your main folder on Jupyter Notebook, now you should see those three new files, those ABI L2 AODC, which stands for AOD CONUS data files. Okay, so let me go back. All right, so again, I'll scroll back up. So again, these are the settings. So you want to select these settings with the pull-down menus and then run block, and then click on block 6 and run it, and answer yes to the question. All right. So are there any problems or questions or problems in the Slido, Bill?
Nope.
Okay.
I also looked at chat. So
chat. Okay.
So there are no indications that people are having trouble.
Okay, great. So let's do this. We are running behind, but still, let's take a short break. So I have it as 2:02, so Eastern time, PM Eastern time. Let's come back in about 5 minutes. So at about 2:07. And then we can run the second Python code file, which is where we're going to actually read in the data files and visualize them with Python. Okay, but let's take a short break, give people a chance to walk away for a minute. Actually, I'll just leave this up here, just like this.
Yeah, and this would be a good time for additional questions if people have it in Slido.
Yeah, absolutely. And if you're having like a complete, like this is not working at all for you, don't worry about it. Just email me after the session and I can work with you and we can figure it out.
So Amy, you might want to put your email then in chat or something, the one you want people to get.
Well, yeah, it's on the slides, but yeah, that's a good idea. Let me put it in the chat too.
And Amy, you've had a few people drop off. Hopefully people will hang in there just to see how things go, even if they have a little bit of trouble.
I hope so. But, you know, not everybody may want to use Python. That's understandable.
since we have perhaps another minute, there was a question concerning the certificate for this, for each of these sessions, and will there be somebody who will email the certificate to everyone? So, Gary, I think the answer to that is yes.
That's correct. It will come from AMS.
Okay.
Okay, so on my clock, it's been about 5 minutes. So while people are kind of filtering back in, let me just show, just demonstrate, and people, participants, I don't want you to do this, but I just want to demonstrate, at least right now, but I just want to demonstrate how these menus work. So if you wanted to use this file to download, some other ABI level 2 product, or even Aerosol optical depth for a different day or a different satellite, all you have to do is just adjust the menus. So let's say, for example, we wanted to, instead of GO 17, we wanted to look at GO 16. And then let's say, starting at 2055, let's say we wanted to end, instead of at 2110, we wanted to end at 2120. So all you have to do is just change these menus. You do not have to rerun block 5, okay? So just adjust these menus and then come down to block 6 and run the last block and run that again, okay? So now you can see when I run that, now we have a different list of data files. So there goes 16 and there's more of them. So I don't want to save these, so all I have to do is either type no or type N and enter, and then the files won't be downloaded. See, I get this message that says files are not being downloaded. Okay, but it's that easy. So again, all you do is you just run block 5 once. Block 5 is the one with the pull-down menus, and then you can go back as many times as you want and change the parameters in the menus, and then rerun block 6 again, and it'll list and download additional data files. Okay. All right. So I'm going to close. That's fine. I'm going to close that file. And so now I'm going to go back to my home page, and I'm going to open up the final file, the one that says VIIRS ABI AOD L2 process visualize. Let's click on that. Or I should back up. So now, again, on your home page, your main folder, I should say, you should have 4 NC files. So you should have the one VIIRS one that I gave you, and then the 3 ABI ones that we just downloaded. Okay. So let's click on the process visualize code file, and then I'll just take a second to open up. All right, and so this one works pretty much the same as the last one. The only difference is that after we run block 0 that has the documentation, once we start getting to block 1, all the blocks, except for the very last one, we won't see any output, okay? They're all essentially just functions that we're running, all right? But I'll go through and I'll explain what those functions are doing. So this first one, so I'm in block 1. This is where we import our Python packages again that we need. And so the key ones for this code are netcdf4. So this is what's going to allow us to actually open up the AOD data files and read them. And then we have various matplotlib features. Matplotlib is the main plotting library, so to make any kind of plots or graphs. And then cartopy, that's the library that is used to create maps. Those are kind of the important ones for this particular file that we're running. So let's run block 1, okay? And then that brings us to block 2. So again, what we're doing with this file is we're going to work with either ABI AOD data files or VIIRS AOD data files. So this first function is the one that's going to allow us to open up the ABI AOD data file. and select the AOD data using quality flags. Okay, so the first thing we're going to do is, this is a function that we're making. So we're going to read in our AOD data. Okay, and the variable name is called AOD. All right, and then we're going to read in here the data quality flag. So remember, that's what allows us to select high, medium, or low quality AOD data. And the variable name is DQ, capital DQF. And so then we have some if statements that allow us to select high, medium, high, I should say high, top 2, which is high plus medium, or all qualities data. And then down here, so this last part of the function, ABI data files, most of them, including AOD, they do not include latitude and longitude as variables. All right, and this is in order to save space in the AOD file. So what that means is that we have to kind of go through a process where we calculate latitude and longitude. And so in the supplemental slides that I provided to you, it talks in more detail about this process. So I'm not going to talk about it here, but just be aware this is what we're doing with the ABI AOD data file. We actually have to calculate latitude and longitude. So let's run this block. Okay. And so now I'm on to block 3. So we're going to do the same thing, but now for the VIIRS AOD data files. But except it's a lot easier because VIIRS data files do include latitude and longitude as variables, so we don't have to calculate them. All right, so the first thing we're going to do is we're going to read in the AOD data. And so you can see that the variable file name is slightly different. So it's AOD 550, whereas the ABI AOD was just AOD is the name of the variable. And then here, the data quality flag for VIIRS is called QC all. So again, it just has it's the same concept, but it just has a slightly different variable name. And so we're going to have our if statements now to select our VIIRS AOD data quality. And then down here at the bottom, we're going to read in the longitude and the latitude from the file. Okay, so let's run that block. All right, so now I'm on to block 4. So this is where we're going to create our color bar. And so the color bar is, this code is a little bit unique because it's going to make our color bar that's independent of plotted data. So that means it doesn't depend on the data that we're actually going to be plotting. And that's important when you're making more than one map. You want the color bar to look the same for all of them. And the other thing this color bar does, it's auto positioning, meaning that if you change the domain or the size of the figure that you're making, the color bar position will change automatically. And that kind of, it's nice, it just saves tedious steps later on. All right. So a couple things, where are they? So right here, this command is where we're actually calling the specific color bar. And we're also going to set a color for AOD values greater than 1. So those are those really thick aerosols. And so these are 2 variables that we're going to define. So palette, this is where that's what we're going to use to set the actual color map itself. And then we're going to pick a max color. So just be aware we're going to do that at the very end. So let's run block 4. Okay, so now block 5. So this is essentially we're gonna create an array that will set the contour, so the start and end point and the intervals for when we plot the AOD. We're going to use a plotting function called a filled contour plot. And so essentially what the contours are doing, they're just going to set how fine or how coarse the AOD data are plotted. So that's what this function does. So, and we're going to set that contour interval again at the very end. So let's run block 5. Okay, and so now I'm on to block 6. So this is where we actually format the map that we're going to make. So there's several different aspects here. So the first thing is we're going to set up the latitude and longitude grid. Then we're going to format our latitude and longitude ticks. And so let's see. Then we're going to actually format the grid lines. And so you may decide you don't want grid lines and you can just delete this part of the code. Don't do it now, but I mean later if you want to modify this. I've also made our grid line silver. Again, maybe you don't like silver, so at some point you may want to modify this code. You can change it there. And then the last step is we're going to draw coastlines and borders. And we're going to do that using the natural earth feature shapefiles. And so you can see them there. So I'm going to plot ocean, land. Lakes are twice because once I plot the actual shape of the lakes and then the outline themselves. And so then we have our country borders and then our state borders. Okay. And then the last step is to set the actual domain. So the latitude and longitude, the four corners of the map that we're going to make. So let's run block 6. Okay, so now we're on to block 7. Let me just take a drink of water here. All right, so block 7, this is optional, but as you remember, these fires were near Los Angeles, the city of Los Angeles in California. So I thought it might be nice to add a marker that would designate Los Angeles. So we're going to use the natural earth feature shapefiles in order to do that. So this little function allows us to basically set the name of the cities and then the size of the marker and the font size for the city label. So let's run this one, and we'll do all that at the end. All right, so now I'm on to block 8. So we're going to want a title for our plot. So the next two functions, block 8 and block 9, will automatically generate a title for our plot based on the information in the data file. So this first one is for the ABA data file. So it just pulls out the information, it pulls out the dates, and then it's going to also use pull out the satellite and then the observation day, and for ABI files, the observation time as well. I'll pull all that automatically from the file name. So let's run block 8. And then block 9 is the same thing, but now it's for a VIIRS data file. So it's going to pull out the dates, and it's going to pull out the satellite. Either it's going to be NOAA 20 or SNPP, and then we're also going to include the AOD data quality. So let's run block 9. Okay, so block 10, this is where the actual plotting happens. So there's a lot of steps here, so I'll just kind of go through them. So the first thing is we're going to set up a figure. And we're going to use a projection, a map projection. So here we're using the plate carré map projection from the CartoPy package. So I have a comment here explaining what that is. It's an equidistant cylindrical projection. You can use certainly something different. There's a lot of options in CartoPy, but this is just nice, especially for beginners. Then we're going to read our map settings function in. Then we're going to add our plot title. So it's either going to be the ABI or VIIRS plot title. That's going to happen automatically. We're going to add our color bar. We're going to add our city names. In this case, it's just Los Angeles. Then here's where we read in our AOD data and our latitude and longitude. So either VIIRS or ABI, depending on what our file is. This is where we read in our data contours that we set, and then the color map and the color that we pick for the AOD data that are greater than 1. All right, and so then right here, this is where we run our filled contour plot of longitude, latitude, AOD data, and then we have the contours for plotting, our color map that we selected. Extend equals both. That means that we're going to plot any data. So I should back up. So again, we're setting our AOD data range from 0 to 1. But if you remember, there are AOD that could be as low as minus 0.05. And we could have AOD between 1 and up as high as 5. So extend equals both. We'll plot any data that are higher than 1 and lower than 0. Okay. And then again, we want to include the plate carré map projection here. All right, and so then we're going to actually show the plots, and then we're going to save the file with a file name that we generate automatically, again, from information that's in the data files themselves. And the last step is that we're going to close the plot so that we can build the next one. All right, so let's run block 10. Okay, and so now block 11, this is our last block. Hopefully everybody's still with me at this point. So this is where we're going to enter our user settings, and we're going to actually make our figures. Okay, so because we have 4 AOD data files in our folder here, we're going to make 4 individual maps, okay, and files that are saved. So the first thing is And again, it's up to you, but I wouldn't recommend for the first time. Just keep everything as it is, and then if you want to run this again on your own, you can kind of play around with these different settings. And and I encourage you to do that to see all the different variations that you can do. Okay, so the first one is the file path, and that's where the AOD data files are located. And again, I have this set to the current working directory, which is the folder on Jupyter Notebook where you have this code file. The save path is where the directory where the image files that we make, where they're going to be saved. And again, I have it set as the current working directory, which is the folder here, where the same folder where the data files are. Save format. So this is the format for the files, the mapping files that you save. So it could be a PNG, it could be a JPEG, a PDF, and then there's some other options as well. You can see them all there. Under data settings, this is where you can pick the AOD data quality. So it can either be high, top 2, which is high and medium, or all, which is high, medium, and low. So let's keep it top 2. And then the contour interval, again, this is where we're setting the AOD interval, contour interval for plotting. 0.05 is a good choice. If you want something that runs slightly faster, but has a more coarse resolution, you can change that to 0.1. 0.01, the program will run more slowly, but you'll have a finer resolution of your final map. So somewhere in the range between 0.1 and 0.01 is what I recommend. All right, in terms of plot settings, this is where you're going to set the color map for the color bar and the plots. And so again, these are matplotlib color maps. Rainbow is a nice choice. And then this color here, this is the color for AOD data that are greater than 1. If you're going to use the rainbow color map, dark red is a nice choice for the maximum color. In terms of file resolution, this is the resolution in DPI, dots per inch, for the image of the map that we make. I wouldn't go any lower than 150. If you get too much higher than 300, the actual image files are huge and they take longer. So 300 is a good choice. I would say, at least if you're starting off, anywhere from probably 150 to 300 is a good choice. And then the mapping settings here. So this is where you're going to set the domain for your map and then designate the longitude ticks and the latitude ticks for the map. Just remember, when you're working in the Western Hemisphere, so west longitude, you're going to put a negative sign in front. So for example, 100 degrees west longitude is going to be written as -100. Okay, so that means our domain is going from -121 to -117 degrees longitude, and it's going from 32 degrees north to 35 degrees north. Okay, and then I entered longitude ticks every degree longitude, and latitude ticks every degree latitude. Okay, and then finally at the end here, we have our cities. So again, we're going to plot Los Angeles. The resolution of the shapefile. I can provide links to show you what cities are listed, but essentially 110 meters has only big cities, like very large cities. 50 meters has large and medium cities. 10 meters has large, medium, and smaller cities. Okay. And then the city text, that's how big the font size is for the label on your map. And the city marker, we're going to have a filled white circle indicating the city. And this city marker just designates how big that filled circle marker is. Okay, so I will leave everything as it is for now, unless you're an expert and you want to play around with this. But at least leave it the way it is now for the first time. And then let's run this. So I'm going to run this block. And what it's going to do, again, is it's going to go through each of the netcdf files. We have 4 of them in our folder. And for each one, it's going to do all the steps we went through. It's going to open up the data file. It's going to select the AOD data based on the quality flags setting that we set. In this case, it's high and medium quality. And it's going to plot those data on a map using domain that we specified. And so what's going to happen is that process occurs. Each map that's made, we're going to see that image here as output in Jupyter Notebooks. So the first one was the NOAA 20 VIIRS AOD. We can see that there. And then as we scroll down, now the program is going through each of the 3 Go 17 ABI AOD data files. So it's going to show those one at a time. And as the program, so now we have the second one, is making those files, it's actually saving them back over here. So we can see we have the first 2 PNG files that are saved. Let me go back. And then at the very end, the program will print done when it's finished, so we'll know that it's completely done. So yes, hopefully this is working for everybody. Again, if it's not, feel free to email me and we can figure out what's wrong and get it to work for you. I'm sorry, we don't have more time. We really wanted to try to keep these sessions. Okay, so you can see printed done. So everything's done. So if I go back to my main folder here, you can see now I have those 4 PNG files corresponding to the 1 VIIRS AOD data file and then the 3 ABI AOD data files. And so you can open them from Jupyter Notebook. So you can just click on one and it'll open up in a separate tab. It's kind of huge. You can't really see everything. So what I like to do is actually scroll. I'm in Windows, so I can open up a Explorer window here, and I can actually navigate on my computer to where this folder is. And so when I do that, you can see, hopefully you can see the 4 PNG files. So if you just click on one, it'll open up. Hold on, let me move that over here. It'll open up, and you can take a look. Okay. So just a couple of things. I would encourage you on your own to, scroll back up here, to change some of these settings. So maybe try plotting all qualities data and also high qualities data and seeing what the difference is. Maybe try a different color map. And you can certainly, like, if you wanted to download, different AOD data files, like for example, maybe there's an event that you're interested in that impacted your region, and then you can do that, and then you can change, obviously, the domain of the map that you're plotting, and then the longitude ticks and the latitude ticks correspondingly. Okay, but I would definitely encourage you to play around with this, change the settings, try it, and see what you think. All right. Do we have any more questions in the chat, Bill? For the Q&A, I guess. Since it's 2:30, I'll definitely stick around to answer questions, but if people have to go, I understand.
Well, there was a question, and the question was, if you made a mistake, is it easy to find your error?
If you made a mistake, meaning?
Yeah.
What kind of mistake?
Through all of this and then it didn't come out, I guess.
It's probably easy to figure out what went wrong, but I think we'd have to work one-on-one unless maybe someone can, whoever that person is, can put some more details in the Q&A.
Okay. Well, I actually put up another poll. I thought you might be interested to see who was successful in creating something.
Oh, okay. I am interested, yes.
And so we have people kind of weighing in here. So actually, we have 12 responses. 83% said they were successful.
Okay, terrific.
Other people can go back to their Slido and add to it if they wish.
Yeah, and so for the person that had an error, again, it should be fairly evident at which point you had a problem, because there should be an error message that, so instead of, like, for example, when I run, this is the last block 11. So if this person had an error, instead of seeing the plots, that person should see an error message that will have some indication of what the issue was. Okay. So that if that person wants to email me and maybe include that error message, then we can figure out right away what the problem is.
Well, you had 13% who said they weren't successful, so that out of 15 responses.
I mean, my guess is that those people either don't have the packages installed that they need, or maybe the version of matplotlib wasn't updated, because that'll give you an error message and it won't run the program. Those will probably be the two most common problems.
Okay.
And those are easy to fix. I can work with them to fix that.
Yeah, you had 15 responses and 87% said they were successful.
Okay, great. Well, hopefully this will be helpful. Again, you can use this code with any VIIRS or ABI AOD. You can obviously modify it. Like if you just want to look at ABI AOD, you could make a new Jupyter Notebook code file and just pull out the parts that are relevant for ABI AOD, for example. There's lots of things that you can do. But this should give people a good start, hopefully. All right. Any more questions coming in, Bill?
Let's see, I'll make one last check here. Someone said they got all the packages installed and still got an error.
Okay.
So
all right, well, whoever that is, I would encourage you, please email me and we'll get that sorted out.
Then you had a comment. Thank you very much. This was a very helpful session.
Oh, good. Well, I'm so glad. I hope it was helpful for people.
Okay, I think that's where we.
Okay, that's good. Yeah, I like people to have the tools to actually work with the data themselves. Instead of me just showing a bunch of things, you can actually now, you guys are empowered to work with the data directly yourselves.
And somebody mentioned in the chat that Jupyter tells you which line the error is on. That was Kyle.
Yes, exactly. Yeah, that's what I was referring to. So when you get an error message, the error message should give you an indication of what the problem is. So anybody that did have an error message, if you can just copy that, paste it in an email to me, that'll help us figure out what the problem is.
Okay. So you might just refresh people's memories of the next dates again.
That's a good idea. Okay. Let me put that back up. Yeah, so don't forget about session 3 on July 28th. So that's monitoring marine heat waves with satellite sea surface temperature, data using ERDAP. And then session 4 is on August 11th. That's monitoring changes in sea ice at seasonal and near real-time timescales. And both of those sessions are led by Dr. Kara Wilson.
Okay. So maybe we can turn it over to Dr. Wang and for any last comments.
All right. I just want to say thanks everybody who joined. I appreciate it. I hope it was a useful session for you.
Yeah, thanks for everybody to join. I just to say that I work with undergraduate students a lot. Like even this summer, we work with about 10 undergraduate students. And the working group has worked hard in the last 12 months to get all this together. And the reason we pick up the summer is because summer is more or less, you have more time, kind of free time. And you can do a lot of things in the summer, obviously, to recharge, but also think a little bit more broadly about things that you may not learn from textbook, but you could learn from the sessions like this. So anyway, I hope you can continue to join us and get some homework done, at your time available. Summer is pretty long, so you can, will be a good time to plan ahead. So we would like to see you again in the next 2 sessions. Thank you. This ends our second session. Thank you.
Okay, see you next time.
Thanks for your help today, Bill. I appreciate it.
No problem. There was another question from Kyle that asked whether you could help with other Python problems than what you talked about today.
Not really, no. It seems like every class we have people email me and they want me to like check their code for unrelated issues. Yeah, I can't really do that. If it's a simple question, I'm happy to point you in the right direction. But anything more than that, yeah, I can't really do that.
All right, very good. All right, Amy, have a good day.
All right, thanks, Bill. So, Jen, should we stay on a little bit more, or should we a little longer, or should we close it out? Maybe Jen's gone. Okay, everybody. It looks like most people have logged off, so I'm just gonna stop the session. Okay, thanks, everybody.